How can objects push on each other even though they are not touching? Most people will think magnets, which is exactly what we are looking at. But how do magnets actually do that? When you take two repelling magnets and bring them closer together, it feels as if there's something in between them, as if something is preventing them from touching. What is between the magnets? Let's see what we can't see between the magnets. If we place a single magnet under a piece of white paper, then sprinkle iron filings on it, this is what we see. Scientists call this a magnetic field, and all magnets have a magnetic field surrounding them. To understand why magnets push on each other without touching, we need to pay attention to the pattern we see with the magnetic fields. We notice this looping pattern that occurs around the magnet. You can see this on the top and the bottom of the magnet. Now we will focus on two repelling magnets that are far apart. When we sprinkle the iron filings on the magnet, this is what we see. What you want to pay attention to is the area between the magnets and how those magnetic fields are not interacting too much. When two repelling magnets are far apart, we don't feel anything between them. This doesn't mean the magnetic fields are not there. It simply means that the fields are not interacting much. We notice this with the patterns of the magnetic field lines shown. We can see that the magnetic fields do not interact much, and the pattern of the magnetic fields appears similar to those in a single magnet. When we bring two repelling magnets closer together, we can start to feel the magnetic field between the magnets. If we sprinkle iron filings on the magnets, this is how we would see the fields change. If we pay attention to the patterns of the two magnetic fields, they are starting to look less similar to a single magnet. As we bring two repelling magnets closer together, we start to feel their magnetic fields interact, but we can also see how the shape of the fields change. It is almost as if the fields are getting squished together. When these fields get squished together, that is when the fields will push on each other, because the magnetic fields are in contact with one another, just like what we see happening with the magnetic fields of the two trains. When the fields collide and touch, they push on each other. Now we can conclude that magnets can push on each other even though they are not touching because of the magnetic fields that surround the magnets. When we bring two repelling magnets close together, their magnetic fields actually touch each other and interact. So even though we do not see the magnets touch, the fields between the magnets do. This is very similar to what we observed happening when the two coins collided. So when you have magnetic fields pushing on each other, it's just like the two coins colliding. But instead of the coins in contact with each other, we now have the fields in contact with each other.